All right, Integrated Math 3 distance learners. So this video is to give a little extra help and practice with comparing functions. So we have an upcoming test. The Delta Math you did should have plenty of practice for what you need for that test. What's going to be on there is transformations, average rate of change, the function equality questions that were from Delta Math, and then also there's going to be a couple questions about this, which is comparing functions. So we're going to look through, there's 11 examples. If you have not yet done this quiz, by the way, your questions are going to be out of order from this. I have this randomized, so it's going to be in random order. But we're going to just talk through these questions a little bit, and I'm going to explain your thought process behind the answers you come up with, okay? So on your test, you'll see these three question types. Which one, we'll talk about the y-intercepts of four functions. So you have four functions presented. Here I only have two, but you have to figure out which one has the lower y-intercept, higher y-intercept. It could be either or, odd, even degrees, and then also greatest degree, least degree. Those could all happen. So that's what this practice is for. If you have not taken this yet, I'm going to put a link. I'm going to pause this video. Don't go on. I want you to try them all first. Okay, this is practice for you for that test. All right, and then see how you do, and then continue the video, and we can talk through each question. Okay, so if you haven't done that, go ahead and do that now, and you'll log in with your student email. It should just go straight to your email account, and you can take this. Okay. All right, so looking at these functions, by the way, it's kind of hard to see. I put the directions up here if you're having trouble to zoom in using the control and the plus button. So if I do that, actually, does that not work? Hold on. Yeah, it zooms me in, which is pretty good. Or if you're using this on your phone, there's a phone app that you can do this. You can zoom in and out like you would with a phone. Okay, we're probably going to use the phone app. That actually looks pretty good. Okay, so the first question, which one of these functions has a lower y-intercept? Well, you can see it gives us one, c of x. It says a linear function. It crosses the y-axis, and it tells us here that's the y-intercept, 0.19. So that's all we care about. We don't really care about much of the rest of this if it just wants to know y-intercept. Then we go to this one. Here's a table. N of x, which, what are we looking for? We're looking for where x is 0, and we see -8. So right away, this one's not so bad. We know that this y-intercept is greater than this one, which we're looking for the lower. Okay, so we're going to go with n of x. So I'll bubble that in. Okay, that's how you do that. Now, which one of these has the greater y-intercept? And a lot of this requires your knowledge of how to find these things. The first part of our unit was, or of this year, has been characteristics. So you should have learned how to find the y-intercept. Now, the y-intercept, this is a standard form quadratic. So we have this downtown coffee shop, and the last number is actually the y-intercept, which we're getting 71. Then we read this, a quartic function that opens down and has one maxima and 0 minima. The function crosses the y-axis at 0.9. So right there, that's really all we're caring about. The rest of it doesn't really mean much. We're just looking for information about the y-intercept. So besides just knowing that that last number is the y-intercept, we could plug in 0 to get the answer for a function. Plugging in 0 always produces the y-intercept for any function in any form. And normally I would recommend to do that. By plugging in 0, all this becomes 0 except the 71. So in this one, it's r of x, okay? Which is the downtown coffee shop. All right, next. Which function has the lesser degree? So first off, I need to write on this a little bit, so I'm going to do that. Let me copy this. We'll pull this up on my whiteboard. Make a new one. Paste. Let's enlarge that. Okay, so we have these functions here. So we're talking about a cubic cubic, what does that mean? Well, that means the degree is 3. So that's what we wanted to know. So if I'm looking at these functions, I'm looking for the terms that tell me what it would be. So we're interested in lesser degree. So that one has 3. Now we want to know how to find it from a table. So I had a video in the notes about how to do this, and this is all about the differences in the table. So here are the x values. We don't really care much about those, but we're looking at the y values. So what's happening as I go from here to here? Well, how much I added, so I'm going to say plus 14. Then from here to here, it was plus 10. Here to here, plus 4. No, 6. Then from here to here, plus 2. Here to here, minus 2. Here to here, that is minus 6. Then from here to here, minus 10. Here to here, minus 14. We can start to see a pattern that's occurring, but what we were looking for, if you remember from the video and from the notes, is we're looking for constant values in this column, and we don't have that yet. So we know that it's not linear. Let's go again. Here, what's the pattern? Minus 4. And then what's that? Minus 4. So now we're starting to see something that is becoming constant. So it's subtract 4 every time on that second row. So what we do to determine the degree from this is we count the number of rows. So here's 1 row, here's 2 rows, and this is our degree. So for this one, t of x, the degree is 2. So what was our question? It wanted to know which one was the lesser degree. So let me pull that up. Lesser degree, so we would say t of x. There it is. Next, which function has an odd degree? So we look here. Look at the function on the right. Degree is highest power. Okay? You need to remember that rule. That was from the very first unit we did, part of this unit. So what is the highest power over here? Well, it's 4. So that one is 4. Okay? And then what about this one? Well, there's a couple ways to do it. First, usually and almost always, the degree is equal to 1 more than the number of extrema. So how many turns are there? 1, 2. So we should be assuming that this is 3. It's also exactly equal to the number of zeros. So 1, 2, but this one has that multiplicity. So that should have come up last chapter as well, or last part. So the degree should be 3, this one's 4, and we want to know which one has an odd degree, so that would be h of x is odd. All right, which one has a lesser y-intercept? This is the exact same question, but how do we find the y-intercept? You'll notice, you remember from the first one, not that one, this one, how it was just like this last number? That's not going to be the case here, okay? Because this last number, that's definitely not the y-intercept. That has a power. So really the rule is this. It's the term without the variable. It's the constant. So negative 720, here it is. Negative 720 is actually the y-intercept for this function right here. That's really low. So it'd be hard to imagine one that's lower, especially from a graph, whereas this one, negative 2. So it's not even close. F of x is definitely the lower y-intercept. Oh, here we go. So which functions have an even degree? So we're going to zoom in. All right. So first off, this one has power of 2, so we know it's definitely even. Here, this describes it as a quadratic for this grain stored function. So that's definitely power of 2. That's even. Here's quartic. That is power of 4. That's even as well. And then what is this? Well, we just talked about that. We had the example up here where we said that this was odd, and it looks just like that one. But the degree is equal to the number of zeros, 1, 2, 3 zeros. So that's a cubic. Also, you have the extrema. It's 1 more than those. And so we're led to believe that this is a cubic, so it's not even. So here it says select all apply, even degree. So it's going to be downtown, suburban, and grain stored. So it's those right there. I had to zoom in for that one, but that's okay. All right, which company's function for number of employees has a greater degree? All right, so this one says quadratic, so we know right away Music City Cafe is a degree of 2. What about the steady bike? Are we seeing a power, because it isn't an equation, it's kind of weird, but are we seeing a power that is 2 or more? Okay, we kind of want more than 2. And no, all we see here is this x that has a power of 1. There's nothing else that's being multiplied by. So we're led to believe that this is a linear equation. So it looks like greater degree would go to Music City Cafe. All right, which functions, so I'm at 8, there's 11 total in here, so we're getting pretty close to being finished. Which functions have an odd degree? Okay, so here it says linear. Linear has an odd degree, so we know that that one, it says select all that apply. So we know that this Siki's City, average hourly wage, not really sure what this is asking. It doesn't really matter. But this bottom one here is linear, so that's an odd degree. What about this one? We have 2 x's in it that are being multiplied. And when we multiply that, it'll raise that highest power to 2. There are 2 roots to this question as well, 2 zeros. So it leads us to believe that this is quadratic, or a power of 2, or an even power. So this one should be m of x, or the bottom one, average hourly wage, right there. Number 9, which company's function for number of employees has a lesser degree? Okay, so we got a cafe and a Christmas tree farm. So this degree over here, we just saw an example like that. This one has a power of 1, and it's not being multiplied by another x like this one was. These are being multiplied. So that is a linear function for sure. So the power is 1. Now let's look over here at the Christmas tree farm. It tells us it's a quadratic. And once we see that, we don't really care about the rest of this. Okay, once we see the word quadratic, we know right then what the degree is. So the degree, the one that has a lesser degree would be the cafe. All right, number 10, which function has a greater y-intercept? So the cubic function crosses at -450. So that's all we care about is this y where it crosses, so y-intercept. And then this one has a y-intercept at 0.3. So technically, t of x has a greater degree. All right, which driver has a larger y-intercept? So this one has one at 0.45. We can see it crossing that y-axis. Look at driver 1, linear function, g of x, it crosses at 0.61. So driver 1 actually has the higher y-intercept. So we're going to put driver 1. And there we go. We submit. All right. I guess it doesn't tell the scores or view the results. That's what we want. All right. You can check your scores. I got 11 out of 11, which I should because I made it. Also, I'm a math teacher. So hopefully this helped in case you missed any and you're confused on why. The test that's upcoming, this will be a concept on there. Okay, if you need to watch the examples from the lesson again, this is really just about, you know, understanding those characteristics, how to find degree, how to find the y-intercept, all of that stuff, odd and even. So that's really what we're going to focus on. But reach out to me if you have any more questions. I can find more help for you, but hopefully this was helpful.